All right, so we just finished talking about multiplying polynomials, multiplying binomials together. Um, and when we multiply binomials, very often they'll give us trinomials. We talked about the FOIL method and or double distributing, or however you want to say it. Now we're going to introduce some special cases where if you can recognize these special cases, there are shortcuts to multiplying these guys together. You don't have to go through the complete FOIL method, okay? So that's the point of today. We're going to talk about squaring a binomial. That's one of the special cases. And then a sum and difference product, which is another special case. So the first thing we have to remember is exactly what does it mean to square something. Now, I know when we did our exponents, we did sort of a shortcut here, that when we wanted to take, excuse me, 4x squared and square that, we would just distribute this squared to the 4 and to the x squared and follow some exponent rules. But what are we actually doing? When we square something, we're just multiplying it by itself. Right? So, why does this distributing the exponent work? Well, because if we multiply 4x squared by itself, 4 times 4 is 16, x squared times x squared is x to the 4th. Okay? And same thing here. If we take 2x to the 3rd, y to the 4th, z to the 6th, and multiply it by 2x to the 3rd, y to the 4th, z to the 6th, 2 times 2 is 4, x to the 3rd times x to the 3rd is x to the 6th, then you get y to the 8th, and z to the 12th. And it's the same as if we're distributing this squared here. Okay? So just wanted to make sure that we remember that while, yes, there is an exponent rule that shortcuts squaring something, when we square something, we're actually just multiplying something by itself. So if we wanted to square x plus 4, then what we could do is just take x plus 4 times x plus 4. And then we could FOIL it if we wanted to. Double distribute. X to the x and x to the 4 would get you x squared plus 4x plus 4x plus 16. Okay? Which we would end up with x squared plus 8x plus 16. Now, something that's kind of interesting, if you start to make a tie between your two monomials in the parentheses, x and 4. Well, if you square 4, what do you get? You get 16, right? If you square the x, what do you get? You get x squared, right? And then take a look at these two terms in the middle. They're both the same. They're both 4x. And if you look even closer, it's what you would get if you multiplied these two together, 4x. That's an interesting pattern. I wonder if it holds true for anything. If we take x minus 3 times x minus 3, then we would get double distribute x squared minus 3x minus 3x plus 9. If you square the x, you would get x squared. If you square the negative 3, you would get positive 9. And then if you multiplied these two, you would get negative 3x, which we have two of them in here. So when we combine like terms, it's the same thing as taking negative 3x times 2, right, because there's two of them. And you get x squared minus 6x plus 9. So it holds true. The same pattern exists in number 4 as we saw in number 3. And so that gets us to a rule that we can use to shortcut this. If we're going to square a binomial, so if we have a product that looks like this, where we're going to just multiply this, something by itself, instead of foiling, we can use this pattern. Square the first term, square the last term, and then we're going to take u times 2. So we're just going to take, for this middle term, a times b times 2, which is 2ab. Okay? And so that's kind of how I say it. You square the first, you square the last, and in the middle, you do u times 2. When you are squaring a binomial, you will have a middle term, and it comes from u times 2. So let's apply it. Okay? If we're going to square x plus 8, well, our rule says square the first for the first term, square the last for the last term, and then take u times u, 8 times x, times 2. 8 times x times 2 is 16x, and we are done. Okay? No foiling. You don't have to worry about double distribute. Think you got it? Try this guy and see what you come up with. Stop the video and bring it back up and see if you're right. Okay? So what'd you get? Square the first term. Square the last term. Negative 3 squared is positive 9. Then we got to go u times u. 2m times negative 3 is negative 6m times 2 is negative 12m. So we get minus 12m in the middle. And we're done. Okay? Try this one. Did you get this? N squared minus 14n plus 49. Okay, we square the first, square the last. Negative 7 squared is positive 49, because negative 7 times negative 7 is positive 49. And then we do u times 2, which is negative 14n. Okay, for the next couple, just stop the video, work it out, and start it back up and see if you got it right. You should have gotten 9x squared plus 48x plus 64. Done. No double distributing. Again, 3x, if you square that, you get 9x squared. You square the 8, you get 64. If you go u times 2, you take 3x times 8 times 2, and you do get 48x. Okay? Try this one. Did you get that? 16x squared minus 8x plus 1. Okay, got one more here. Did you get 25x squared minus 30x plus 9? Okay. If you're not getting these, then make sure you come in and talk to me, and we'll try to find another way to make it make sense. Okay. The next special case is not when we're squaring something. It's not when we're multiplying a binomial times the exact binomial, but if we're multiplying two binomials that have the same terms in them, but one's a plus and one's a minus. Let's see what happens when we FOIL this out. So double distribute the x, and we get x squared minus 9x, and then distribute the 9, we get plus 9x minus 81. Okay, well, combine your like terms, and these guys will add to 0, and you're left with just x squared minus 81. And that's it. Well, that's interesting. I wonder if that happens again. Double distribute here and then here. We get 9c squared. We get negative 12c. And we get plus 12c minus 16. Add your like terms. Negative 9c squared. Your like terms, negative 12c and 12c, are going to add to 0 again. Right? So we get 9c squared minus 16. That middle term added to 0 again, and so it just fell out. Now look at where your final result is coming from. We square the first term here and square the last term here, and then we're just going to put a minus sign between them because positive and negative gives you a negative. And the same thing happened here. Square 3c squared, you get that. Square 4, you get that. And since we have a plus and a minus that we're multiplying together, this becomes a negative, so minus 16. That is the pattern that we're going to use when we have what's called a sum and difference product. So not squaring a binomial, we're not multiplying a binomial times itself, we're taking two binomials that have the same terms in them, but one's adding, one's subtracting. That's your sum and difference product. And when that happens, your middle term will always add to 0, and therefore fall out. So all you got to do is square the first, square the last, and then throw a minus sign between them. That's it. So, if we're going to apply this shortcut, I've got two binomials whose terms are the same, m and 6, but one binomial is addition, one subtraction. That's your sum and difference. So we square the first, square the last, and stick a minus sign between them, and we're done. Okay? Think you got it? Try it here. What would you end up with if you multiplied this sum and difference product? Well, we square the first, square the last, minus sign, done. Always a minus sign because this is positive times a negative, and positive times a negative will always give you a negative. Okay, again, a series of these, so stop the video, give them a shot, start them back up, and see how you do. Did you get 4c squared minus 25d squared? Again, square the first, 2c. If you square that, you get 4c squared. If you square 5d, you get 25d squared, and then you throw a minus sign between them, and you're done. Okay? And that's it. That's all there is to that one. I thought there were more. I think there's one more in your notes, which is this guy. So try him. You can back up one. Try him and see what you get. Okay, did you get m squared minus 9n squared? Okay, hopefully. If not, come in and we'll make it make more sense. Okay? Now, we can use these shortcuts to kind of shorten just about any type of problem. Like one like this. If we want to find the area of the shaded region, which is just that blue sort of border around, then to find the total area, we're going to take the area of that big square, the area of the blue square, and then we're going to have to subtract out that white square that's been cut out of it. Well, to find the area of a square, it's length times width, but when the length and the width are the same, you can just take one of them and square it. So we're going to get 2x plus 1 squared minus x minus 1 squared. We'll shortcut this, right? Square the first one, square the last one, and then u times 2. Remember, these guys have the middle term. If you're multiplying the same binomial times itself, it has the middle term. 2x times 1 is 2x, times 2 is 4x. Minus. Now, we're going to have to keep this in parentheses because we're going to subtract these two polynomials from each other, right? So shortcut it. Square the first, square the last, u times 2 gets you negative 2x. Okay, and then we're going to have to subtract this entire trinomial, so that means we're going to make this a plus and change all of these signs. And when you combine like terms, you get 3x squared plus 6x, and then these ones add to 0, so we don't need it. And then we're done. Okay? All right, try 18. Again, stop the video, start it back up, and see how you did. And hopefully you got 21x squared minus 40x plus 16. Right? We're going to do our shortcut for the 5x minus 4 squared. And then if you square 2x, you just get 4x squared. So when we subtract that, we can change that subtraction to a plus. Change the sign on the 4 to a negative, and then combine these two like terms, the negative 4x squared and the 25x squared. You're left with that. Okay? All right, homework's out in Canvas. Make sure you have that done next time.